Hey guys, it's Miss Giffen coming to you live with your Thursday or Friday at-home assignment. Basically, you are finishing the notes that we began this week, and y'all know I'm having technical difficulties in the classroom, so I'm going to try to record this, and hopefully it will be helpful for you at home. But in class, we began our energy notes, and I have uploaded my PowerPoint presentation to you in Google Classroom. So you have these in Google Classroom. We went through all of our vocabulary in class, or at least most of it. And so you have the definitions for energy. We talked about potential and kinetic energy, the main differences between the two. We listened to my favorite Nutty Professor. You can go back and listen to that song if you'd like. We talked about the law of conservation of energy. It cannot be created or destroyed, only transformed from one form to another. We talked about mechanical energy and how that's the total sum of potential and kinetic energy. We talked about thermal energy, chemical energy, electrical energy, sound energy, light energy, and nuclear energy. So you want to make sure all of your vocabulary notes are up to date, and you can use my slides. Again, this is all in Google Classroom. Today, we are going to talk about how do we calculate kinetic and potential energy. Okay, so I'm going to try to do this on my dry erase board and show you guys how to calculate kinetic energy. Okay, there's one main formula, but it can be written two different ways. Okay, so kinetic energy is 1/2 times the mass times velocity squared. And it's important to note that it's only velocity that's squared, not the whole thing, just velocity, okay? Or another way to do that is just mass times velocity squared divided by 2. Okay, so there are two different ways to write it, two different ways to calculate it to get the same answer. Okay, so this is how we're going to figure out an object's kinetic energy. Okay, our units for energy are joules with a capital J. So your answer is always going to have a capital J at the end. Mass is always in kilograms when we're calculating kinetic energy, and velocity is meters per second. Okay, so let's look at this first problem. And you have this slide at home. What is the kinetic energy of a 4,000 kilogram elephant running at 3 meters per second? Be sure to use the correct units. Okay, so we're trying to solve for kinetic energy. All right, so we know that kinetic energy is mass times velocity squared divided by 2, or 1/2 mass velocity squared. Okay, so let's take the mass of the elephant, which is 4,000 kilograms, okay? And let's multiply that times the velocity squared, which if we look back at the problem, velocity of the elephant is 3 meters per second. So we're going to have to take 3 squared, okay? So 4,000 kilograms times 3 squared and divide that by 2. Okay? So what is 3 squared? That's 9, right? So 4,000 times 9 divided by 2. Well, 4,000 times 9 is 36,000, right? 36,000 divided by 2. And if you plug that into your calculator, you should get 18,000 joules. Okay. Now, you could have also, instead of dividing by 2, you could have multiplied by 1/2, which is the same thing as dividing by 2. But you should get the answer 18,000 joules. Okay? That's how we solve for kinetic energy. Okay? That's the kinetic energy of the elephant. All right, so let's go on to our next slide. And we're going to learn how to calculate gravitational potential energy. So let me erase this real quickly. Gravitational potential energy is really easy. And we've talked about potential energy and the difference between potential and kinetic in class. Okay, you also have some slides on this if you've forgotten. But how do we determine the potential energy, especially of that object that's just sitting on the table? Okay, you know, we talked about the soccer ball that's just laying in the grass in class. So how do we find potential energy? Well, we have to take the mass, potential energy equals mass times gravity times the height. Now, mass times gravity is the same thing as weight. Okay, so we talked about the difference between mass and weight weight involves the gravitational pull on an object. So this mass times gravity is the same thing as weight. So you have to look at your problem to see if they gave you the mass of the object or the weight of the object. Okay? So you can either multiply mass times gravity times height, or if they give you the weight, weight times height. Okay? So that's your formula. Let's look at an example problem, which is on the next slide. Also, gravity, we learned, is always 9.8 meters per second square. Okay, remember we talked about that? Acceleration due to gravity, and gravity is 9.8 meters per second squared. Okay, so let's look at the next problem. If you lift a 50 Newton watermelon to the top of a 2-meter table, how much gravitational potential energy do you give the watermelon? Okay, so if we're lifting this watermelon off the ground to the top of the table, how much potential energy will it have? Well, if we use our formula, potential energy equals mass times gravity times height, or weight times height. So let's look to see. They told us the watermelon weighs 50 newtons. Well, we've talked about mass is kilograms and grams. Weight is measured in newtons. So they've already given us the weight. So we're going to go immediately to 50 newtons times the height. The height of the table is 2 meters. So the height of the table is 2 meters, okay? So to solve this equation, we multiply 50 times 2, which is 100, and it's very important for you to use the correct units for energy, which are joules. So 100 joules is the answer to that problem. Okay? Now, you try the other problems. Try some other practice problems. We're going to go over them in class as well on the day that you're here, Thursday or Friday. But you've got this video telling you how to do it, and you have all the slides that I've posted online. So try to finish all of your notes and be ready to practice with these types of problems in class. I hope y'all have a fantastic day, and I look forward to seeing you soon. Bye-bye.